All right, so get this. Imagine designing your dream house, right, on a computer. Hit enter, and boom, it starts growing right in front of you, like a plant reaching for the sun. Crazy.
Yeah, it might sound like something out of a movie, but honestly, we're closer to that reality than you might think.
Really? Okay, so hold on. No more bricks and mortar, no construction crews. We're talking buildings that assemble themselves.
Yeah, basically. The idea is to create a programmable living construction system. Think about nature, like how a tree grows or how those fungi networks spread. This takes those ideas and applies them to architecture.
So instead of hammering nails, we're, what, harnessing the power of biology. Am I picturing like tiny bacteria with little hard hats?
Well, maybe not construction workers, but yeah, that's the general idea. Genetically engineered microorganisms are like microscopic engineers putting together those building blocks from a blueprint.
Okay, my mind is already blown. How did that even work? What are the building blocks in this case?
Think aircrete, it's lightweight, it's insulating, it makes a solid base. But to really get this to work, we need to guide the growth. And that's where things get really interesting. Imagine a bioelectric scaffolding, almost like a nervous system running through the structure.
Like a roadmap for the bacteria,
Yeah.
telling them where to go and what to build.
Exactly. It's all about precision. Researchers are looking at how to use electrical signals to talk to these microorganisms, guiding them to deposit minerals right where they need to be.
Wait, so we're sending electrical signals to bacteria? How is that even possible?
It sounds crazy, but it's like how plants respond to light or even how our own nervous systems work using bioelectricity. Researchers are tapping into those natural processes.
Okay, I'm starting to get it, but we're still just talking about microscopic stuff.
hmm
How do we go from growing a little blob in a lab to, like, an actual house?
Well, that's where AI and computers come in. Even with simple AI, we can do so much. Analyzing data, adjusting the electrical signals, making sure the growth parameters are perfect in real time.
So the AI is like the foreman on this microscopic construction site, making sure everything runs smoothly. But how do we make sure the final product is actually a house and not just a giant blob of aircrete?
That's where that 3D bioelectric AI-driven scaffolding comes in. Think of it as this super intricate system of sensors and actuators. They're embedded right in the material and allow us to really control that growth, making sure the final structure actually matches the blueprint.
Okay, hold on. Break that down for me. Sensors and actuators, what are those doing in this bioconstruction world?
Imagine a network of tiny sensors keeping an eye on how the material grows, spotting any little deviations from the plan. The actuators can then respond to those signals and make adjustments, on the fly. It's basically a quality control system, but at a microscopic level.
So we're building a house with a nervous system, a brain, and a bunch of microscopic construction workers.
It is pretty wild, and we're just getting started. The potential of this is mind-blowing. With better AI, more sophisticated 3D bioscaffolding, we could build insanely complex structures while using way less energy and resources compared to the old way of doing
All
things.
right, I am officially hooked. But let's be real. How long would it take to build a house like this? Days, weeks, months?
That is the million-dollar question, isn't it? The research is still ongoing, but the potential for speed is huge. Like a small structure, maybe in days. Bigger buildings, more complex designs, obviously longer.
But if we can program this growth so precisely, and the AI is always learning, could we speed things up even more? Could we, like, have houses popping up overnight, like mushrooms after the rain?
It's definitely a possibility. As AI gets better and we really figure out how to play with these biological processes, the speed and the efficiency could just skyrocket.
Okay, I'm living in the future. I love it. But before we start growing skyscrapers overnight, we need to know these bio buildings are safe, right? We're talking bacteria and aircrete here, not steel and concrete.
Of course, structural integrity is super important, and researchers are on it. One really promising way is to use hybrid biomineralization. It basically combines different minerals to make things stronger. It's like giving those microscopic workers more tools, a bigger range of materials to work with.
So not just building with one type of bioconcrete, we're talking a whole palette of biomaterials.
Exactly. And as we learn more, we can create structures that are not just strong, but adaptable and resilient. Buildings that heal themselves when they get damaged, or even change their properties based on the environment around them.
My mind is officially blown. But before we get carried away with self-healing houses and bio-skyscrapers, let's reel it back a bit. Real-world applications, where could we see this making a real difference? Like, soon?
Well, imagine disaster relief, for example.
Yeah.
Rapidly deployable self-assembling shelters. They could adapt to the environment, providing safe and sustainable housing after a natural disaster.
Wow, that's incredible. That could change how we respond to emergencies. What about something closer to home, though? Could this change how we build regular houses?
Absolutely. As the technology gets better and more, affordable, we could see it being used to build affordable and sustainable housing all over the world, maybe even help with that growing housing crisis.
This is amazing. But before we all start growing houses in our backyards, let's talk about the downsides. What if things go wrong? What if the bacteria go wild and the house starts growing uncontrollably?
That's a valid concern, and researchers are taking it seriously. They're developing safety measures like genetic kill switches. It can stop the bacteria right in its tracks if things start going haywire.
So like an emergency stop button for your house.
You could say that. It's not just stopping the bacteria, though. It's about making the whole system really robust and resilient. Multiple layers of safeguards, to make sure bioconstruction is both safe and effective.
So it sounds like a lot of thought is going into safety and control with this bioconstruction stuff. But even with all these safeguards, I gotta ask, are we really ready to trust our homes to bacteria and algorithms? What about the human element?
It's a great question. And the answer is it's not about replacing humans, their skills, their creativity. It's about giving them more new tools, new possibilities.
So bioconstruction isn't about putting construction workers out of a job. It's more like giving them a whole new set of skills.
Exactly. Imagine architects and builders working side by side with bioengineers, AI specialists, designing and growing these buildings that are both beautiful and functional. It's a whole new way of thinking about construction.
That's a pretty amazing vision. But let's be practical for a second. Right now, this all sounds crazy expensive. Are we talking biomansions for the super rich, or could this actually be, affordable for regular people?
Right now, yeah, it's early stages, and it is expensive, but like any new technology, the costs will come down. More research, economies of scale, all that.
So we just need to wait for the bioconstruction equivalent of the Model T, something that makes it affordable for everyone.
Exactly. And who knows, maybe one day we'll be growing our own homes with DIY bioconstruction kits.
Okay, I'm officially dreaming of a biogarden shed now. But let's talk about the environmental impact. We touched on sustainability, but how does bioconstruction really compare to traditional methods when it comes to the planet?
This is where things get really exciting. Traditional construction, it's a huge contributor to carbon emissions, using up so many resources. Bioconstruction offers a much more sustainable way to do things.
So eco-friendly houses that are good for the planet. Sign me up. How does that work exactly?
Well, first off, the materials themselves. Aircrete, for example, has a much lower carbon footprint compared to regular concrete. And a lot of these biomaterials can be grown using renewable resources.
So houses made of, plants and natural materials. That sounds awesome. But what happens when the building gets old? Can you, compost a biohouse?
It's not that simple, but the idea of a circular economy is really important here. A lot of the materials can be broken down, reused, so there's less waste, less impact on the environment.
So instead of a landfill, these biobuildings could actually help the environment.
It's a total shift in thinking. And it's not just the materials. The construction process itself is way more sustainable. We're growing these buildings, right? So we use a lot less energy, way fewer emissions compared to those old methods.
So we're trading in bulldozers and cranes for a team of microscopic gardeners.
You could say that. And the best part is these little gardeners are super efficient. They barely need any energy to do their thing.
Okay, this is all sounding amazing, but let's be real. What are the biggest things we need to figure out before we're all living in biohomes?
Scaling up the process is a big one. Right now, most of the research is happening in labs, small scale stuff. We need to figure out how to apply this to bigger, more complex buildings.
Going from a petri dish to a skyscraper, that's a pretty big jump.
It is, but I think it's a challenge we can solve. With more research, more development, we can refine this tech and make bioconstruction a real option for all sorts of building projects.
So a lot of work to do, but the potential is huge. I'm curious, what are some of the most exciting areas of research right now? What are the breakthroughs that could really push this forward?
One of the most exciting things is the development of even smarter AI algorithms and 3D bioscaffolding. The more advanced these get, the more complex, precise, and functional our structures can become.
So even smarter AI, even more intricate scaffolding, what kind of impact could that have on the actual construction?
Imagine growing buildings that can react to their surroundings in real time. changing shape, their insulation, even their color, based on the weather, the sunlight, all sorts of factors. Or buildings that can check their own strength and repair any damage on their own.
That sounds like science fiction. Are we
Yeah.
talking buildings that think for themselves?
Not quite thinking, but definitely responding to the environment in smart ways. We're not there yet, but the potential is definitely there. And that's what makes this so exciting. There's so much we don't know, so much to explore.
So the future of construction is going to be a lot more, well, organic, a lot more intelligent, and a lot more interesting. But before we wrap up this deep dive, let's talk bigger picture. What are the implications of bioconstruction? How could it change the way we live and interact with the world around us?
The implications are huge. Bioconstruction could change not just how we build, but how we think about our relationship with nature.
So not just better houses, but a better future overall.
Exactly. Imagine a world where buildings aren't just structures, but living, breathing ecosystems. In harmony with everything around them. Buildings that clean the air, produce energy, maybe even provide food.
That's an amazing vision. And it feels like we're at the very beginning of this journey. Who knows what incredible bio-creations are coming next? But before we get too lost in our bio-futuristic daydreams, I think it's time to bring this deep dive back to Earth. So we've gone deep into the science, the potential, even some of the challenges of bioconstruction. But before we wrap up, let's bring it back to us, the everyday people who might actually live in these biohouses one day. What should we be excited about? What should we keep an eye on as this tech evolves?
Well, it's a really exciting time, especially if you're into the future of building and design. I think the most important thing is to stay informed, stay curious, keep up with the research, ask questions, and don't be afraid to imagine the possibilities.
So we shouldn't just sit back and wait for the bio-revolution to happen. It should be part of it.
Exactly. This tech has the potential to change everything, so we need to have a say in how it develops, how it's used.
That's a great point. But for those of us who aren't scientists or engineers, how can we actually get involved? Where do we even start?
There are tons of ways to engage with this whole field. Follow the researchers, the institutions doing the cutting-edge work. Go to conferences, workshops, support companies and organizations that are actually making this happen.
So it's about learning, spreading the word, and supporting the pioneers.
Yeah, absolutely. And remember, this isn't just about science and tech. It's about design, aesthetics, the human element. So if you're an artist, a designer, or just someone who loves creating beautiful, sustainable spaces, your voice matters too.
So we're all potential bioarchitects in a way.
I like that. And that's what's so cool about bioconstruction. It pushes us to think differently, to break free from those old limits, and imagine a future where our homes aren't just boxes, but living things.